So, in the ACT lesson, the ACT practice seminar prep thing I taught 2 weekends ago that some people signed up for and didn't show up for, we used this thing called Pythagorean triples. Guys, I'm not kidding you. We used Pythagorean triples at least 5 times in the ACT practice just for geometry, okay? So, we are finally going to learn what this is because it's very, very convenient. So, the first thing I need you to do is I need you to write down what Pythagorean triples mean, okay? So, this is what it means. 3 positive integers, 3 positive integers, A, B, and C, that satisfy the Pythagorean theorem. 3 positive integers, A, B, and C, that satisfy the Pythagorean theorem. First of all, what kind of triangle do we have to use Pythagorean theorem? Okay, so these all have to be right triangles. Basically, what this is it's a chart of 2 legs and a hypotenuse, and whenever you see these 2 legs together, they're always going to have the same hypotenuse. For example, the most common one is 3, 4, 5. So whenever you see a right triangle and it has a leg of 3, a leg of 4, you could use Pythagorean theorem, 3 squared plus 4 squared equals c squared, but don't waste your time because it's going to be 5. Okay? So this is one Pythagorean triple. Another Pythagorean triple would have a hypotenuse of 13, a leg of 12, and another leg of 5. Tricked you, not 11. Okay, so how am I coming up with these? Well, there's no pattern. There's not a pattern I'm memorizing. I just know these Pythagorean triples, 3, 4, 5, 5, 12, 13. So you're like, well, I still don't get it. Well, 5 squared plus 12 squared equals the same as 13 squared. Do you see? Okay, so it's kind of like a trust thing. Like, trust me, these 2 equal this. 7, 24, 25.
Is it like there's always like 2 consecutive lines?
Maybe. That's a very good hypothesis. She said, is there always 2 that are back to back? 3, 4, 12, 13, 24, 25? Because, well, not necessarily back to back because this one is 8, 15, 17. But then you have 9, 40, 41, and 11, 60, 61, and 15, 112, 113. So close beside this one.
So
most of the time, yes. So, Miss Jenkins, are we going to have to memorize these? No, you don't. Please let Taylor in. I would, if I were you, I would probably memorize the first 4. Remember, even if you don't memorize these, how could you find them? By doing Pythagorean theorem. But on the ACT, if you did this 5 times, it could save you minutes, right? Yes, ma'am.
If it's a multiple, like 6, 8, and 10, is it still the same?
You know what? That is leading me to a very great statement that has a star down here. Any multiple of a Pythagorean theorem is also a Pythagorean triple. For example, 3, 4, 5. That's a Pythagorean triple. If I multiply all of these by 2, 3 times 2 is? 4 times 2? 5 times 2? This is still a Pythagorean triple. Yes. Okay. Okay, this part down here is not actually part of our lesson, and it confused the skittleness craziness. I don't know what word I was about to say. Out of first period. So I'm going to skip it for now. Because I did not mean for it to confuse them as much as it did. And it's not part of this chapter. It was just kind of like a side lesson. So we're going to come back to this, okay? We'll come back. No, actually, I just think you need to know it. It's important. Okay? Okay. It's just me being a little extra. As Pablo likes to say. He calls me extra. All right. Here we are, Glenda. Gloria. Sorry. Gloria. Gloria. All right.
Can we listen to the Get Tricky With It song?
No, not right now. We will on Thursday. Yeah. We will on Thursday. All right. So good. All right. So our lesson, this is 8-2. We will only spend one day on this lesson because it is literally covering the Pythagorean theorem, which sometimes I underestimate. I feel like y'all know this like the back of your hand, and then I realize we don't know it as well as we should. So I'm going to slow down, and let's go over this. Remember, c squared is always across from the biggest angle. We can only use Pythagorean theorems in a right triangle. So your c squared is always across from the right angle. So if we want to find a, we would have a squared plus 12 squared equals 13 squared. But pause. I could use Pythagorean theorem, right? I could. But isn't this a Pythagorean triple? 12, 13, what? So A is, see how much time I just saved? Do we recognize 20 and 30? Huh? Is that one of our Pythagorean triples? 20 and 30?
No. 20 and 31?
Yeah, it's a multiple of 5, but it reduces to 4 and 6. Okay, so let's use Pythagorean theorem. So we're actually going to find our c. So it would be 20 squared plus what?
30.
Okay, so 20 squared is 400. 30 squared is 600 equals c squared. 400 plus 600 is 1,000. C squared. How do I cancel out the squared? Square root. Square root of 1,000. Okay, here's the deal. I do not want a decimal. So, off to the side. Let's break down the square. Oh, I'm sorry. My B. That's 900, not 600. So that's 1,300. Okay, so, sorry. 1,300. Let's see what can break down into 1,300. Yeah, 100, but that takes me to 13. And then I could have 10 from it, though. So you'd have 13 and 100, and then I'd have 10 and 10. That's as far as I could go, though, right? So my answer would be 10 square root of 13. All right, I want you to try 1 through 4. Don't give me a decimal. I'd rather it be a really big square root than a decimal. What y'all think? Y'all take your answers with mine? Questions? What y'all think about number 3? Okay, so here. Okay, so when you're squaring these, you have to square the top and the bottom. 4 squared, 9 squared. Then I subtracted common denominators, so your denominator stays the same. 25 minus 16 gave me 9. Then when you take the square root, take the square root of the top and the bottom. Square root of 9 is 3, square root of 81 is 9. Then 3/9 reduces to 1/3. Hey, question. I just noticed this, so I don't expect y'all to always see it. 9, 9, right? Look at the top. 4, 5. 3. Why? Do you see it?
It's technically multiple.
It's, well, 9, 9, 9. Okay? Look at the tops. 4, 5. What's the other one going to be? 3. So 3/9 reduces to 1/3. You see what I'm talking about? Okay, what other questions on those? Okay, all right. So you see how some of them reduce and some don't? 3 squared and 3 squared made the square root of 18. 18 reduces to 9 and 2. Square root of 9 is 3. Square root of 663, I didn't get that to reduce. Square root of 1,345 is divisible by 5, but I didn't get it to reduce to anything else. Did you? 269, but I couldn't get that to break down either. Okay, so then there's this thing called the converse of Pythagorean theorem. It helps us classify triangles. Here's how it works. If a squared plus b squared equals c squared, then it's a right triangle. That's what we've been doing. If a squared plus b squared is greater than c squared, it's acute. If a squared plus b squared is greater than c squared, it's obtuse. So if c squared is greater than those, it's obtuse. If these two are greater than your hypotenuse, it's acute. That's how I think about it. If my hypotenuse is bigger, obtuse. If these two are bigger than my hypotenuse, acute. However, here's one thing you have to do. There's like a pre-step. Do you remember before Christmas when we determined what makes a triangle? What makes a triangle? The two smallest sides have to be greater than the third. Two smallest sides have to be greater than the third. Now I'm not going to tell you which one, but one of these does not make a triangle. So you have to check every single one of them before you start. So that's our first step. Two smallest, 30 plus 40, that is 70, right? So 70 is greater than 50. Can we start? Do they make a triangle? Okay, so we can start. Now let's determine whether it's right, acute, or obtuse. Here's what I do. 30 squared plus 40 squared. Well, what do you think? It's right, because 30 squared plus 40 squared equals 50 squared. Yeah. First step, what do I do? I think it's time to pull out my handy dandy little popsicle stick. Taylor, first step, what do I do? Which is? What's 20 plus 30? Is that greater than 40? Okay. So did they make a triangle? Okay. So we can move on. Jalen, what's my next step? Okay. So 20 squared plus 30 squared equals 40 squared. I got 1,300 to 1,600, which means c squared is greater, which means it's what? You try 7. What'd you get?
Right.
Hey, will y'all open the door, please? Hello. He is in the junior meeting. What happens when we square a square root? It cancels it, right? So, but here's the thing. Before we start doing that, we have to determine if these even make a triangle. So take the two smallest, the square root of 5 plus the square root of 12. Is that greater than the square root of 13?
Yes.
Yes. Okay, so we can move on. Now, when you square the square root of 5, it just becomes 5. When you square the square root of 12, it just becomes 12. So then 5 plus 12 is 17, which is greater than 13, which makes it cubed. Okay, you try 9 and 10. Ding, 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 ding. Wait, what kind of triangle is number 9? Why? 18 equals 18. The two smallest sides are not greater than the third. We cannot classify 3 sides if they don't make a triangle. Good job. Marshall, does number 10 make a triangle? Okay. So I would do 2 plus the square root of 8. Is that greater than the square root of 12? Yes. So then I'd square everything, so that's 4 plus 8, which equals 12, so it's a right triangle.
Bless you.
Okay? Alright, if you turn to the back, we have practice. And I want you to do the odds. Odds. Because you're a bunch of oddballs. You're welcome.